Behind this black hole sits a star dead center, completely blocked. Every telescope on Earth should see nothing. Instead, they see this, the hidden star stretched into a perfect ring of light. That ring shouldn't exist. Let's find out why it does. In the next few minutes, why gravity isn't really a pull, how light can turn without ever bending, and how this impossible ring, an Einstein ring, became one of astronomy's most powerful tools. Start with what gravity really is. Newton imagined a force reaching across space and pulling things in. Einstein saw it differently. Mass curves space and time around itself. The Earth doesn't feel a pull from the sun, it just follows the straightest possible path through space the sun has bent. Gravity isn't a tug, it's geometry. And that changes everything for light. Light has no mass, so a Newtonian pull should barely touch it, at best a tiny bend. But light travels through space and the space itself is curved. Einstein predicted starlight grazing the sun would shift by exactly twice the old number, 1.75 arcseconds. In 1919, during a total eclipse, astronomers photographed stars right at the sun's edge and they had moved. Einstein's number, gravity bends starlight. Now replace the sun with a black hole, far more curvature packed into a single point. Light passing far away bends a little. Closer it bends more. And at 1.5 times the horizon's radius, light doesn't pass at all, it orbits, circling forever on the photon sphere. So put a star exactly behind the black hole, light going above, below, left, and right all bends back toward you by the same amount. Every one of those paths converges on your eye at once. You see the star not in one place but everywhere around the black hole, a full circle of light, an Einstein ring. Nudge the alignment and the ring breaks into glowing arcs and multiple copies of the same object. Telescopes photograph these rings all across the sky, and they're not just beautiful, a lens magnifies. Gravitational lensing is nature's telescope. It reveals galaxies too faint to see on their own, and it weighs the invisible. Dark matter shows itself only by how it bends the light passing through. Even the first ever photo of a black hole, that bright ring, is mostly lensed light bent around the shadow. So a black hole doesn't just trap light, it redraws the sky around itself. Gravity bends the messenger, but the message still arrives. Next, what happens to light that drifts too close and falls in? Subscribe so you don't miss it.